What if Starship never returns to Earth? The one-way space megastructure. Starship is constantly framed as a rocket that launches, lands, and fires again. Reusability is treated as the whole point. Missed the landing and the mission failed. But that assumption hides the version of Starship that actually changes how we build in space. The moment you stop designing it to return, Starship stops being a vehicle and starts becoming infrastructure. By the end of this video, you'll see why NASA is already planning to leave some of them in orbit permanently and what that unlocks next. What if I told you the most powerful rocket ever built wasn't designed to come home? Everyone assumes SpaceX's Starship is all about reusability. Launch it, launch it again. But here's what most people miss. There is a hidden potential in Starship that could change everything we know about building in space. And it starts with a simple question. What if we stopped bringing them back? Think about it. Starship stands 121 meters tall and weighs 5,300 metric tons when fully fueled. That massive upper stage alone can haul 100 to 150 tons to low Earth orbit. That's more cargo capacity than any rocket in history. SpaceX designed it to deploy entire space station modules and giant telescopes. Elon Musk himself called it one of the most profound things that's ever happened, comparing its impact to major evolutionary steps in human civilization. But here's the catch. All that reusability comes at a cost. Every Starship carries heavy heat shield tiles, massive landing flaps, and reinforced legs. All that hardware is dead weight if you're not planning a return trip. Both engineers and NASA know this, and they're already planning something wild. NASA's Artemis lunar program needs multiple Starships to refuel a crewed lander in orbit. They estimate it'll take somewhere in the high teens of launches per moon mission. But here's the twist. Some of those Starships will never see Earth again. They're building drone tankers with no heat shields, no flaps, just fuel tanks wrapped in insulation blankets. These ships will stay in space as orbiting gas stations, permanently parked and ready to refuel the next mission. And if NASA's already doing this, what else becomes possible when you stop thinking about the return journey? Most people think one-way missions sound crazy, but the real madness is ignoring what they unlock. The moment you remove re-entry from the equation, everything changes. No more heat tiles, aerodynamic surfaces, or landing gear. Suddenly, you've got tons of extra mass to work with. Musk has floated the idea of stripped-down expendable Starships that could send massive payloads on one-way deep space trips. He's even suggested using a Starship hull as the structure for a giant space telescope with more than 10 times Hubble's resolution. But the most ambitious idea? Tethering multiple crewed Starships together and spinning them to create artificial gravity. Imagine that, not just one ship floating through space, but a cluster of ships rotating like a giant pinwheel, giving astronauts Earth-like conditions on their journey to Mars. The problem is no one's actually built anything like this. These aren't funded programs, they're thought experiments, and thought experiments don't keep astronauts alive. You'd need docking ports on every ship, structural connectors, integrated power systems, life support networks, and radiation shielding. Basically, the engineering complexity explodes. Yet the numbers tell a compelling story. A single Starship has around 600 to 1,000 cubic meters of interior volume. That's 135 times the volume of the Apollo lunar module. If you docked just 3 or 4 Starships together, you'd create a habitat rivaling entire space stations. The International Space Station took 42 separate launches over the years to assemble. With Starship, you could match that scale in just 3 to 5 flights. The hardware to make this happen exists in pieces, but nobody's putting those pieces together yet. Here's where most space enthusiasts get it wrong. They confuse possibility with practicality. Yes, you could theoretically dock multiple Starships and create a massive orbital station. The ISS weighs 420 tons and has 388 cubic meters of pressurized volume. 3 Starship launches could deliver equivalent mass. NASA's planned Lunar Gateway is tiny by comparison, just 63 tons and 125 cubic meters. A Starship-based station would dwarf it completely. But here's what the optimists ignore. The ISS isn't just mass and volume, it's dozens of specialized modules, laboratories, docking nodes, life support systems, solar arrays, and radiators. Everything was carefully integrated over decades. The Starship station would need all that complexity compressed into a handful of launches. You'd need closed-loop life support for air and water recycling. You'd need power generation and thermal management. You'd need protection from cosmic radiation and solar storms, because that thin stainless steel hull won't stop much. And don't forget orbital mechanics. A Starship left in low Earth orbit faces atmospheric drag. It would need periodic boosts to maintain altitude, burning propellant continuously. If you're using it as a fuel depot, you've got another headache – cryogenic boil-off. Even with multi-layer insulation, keeping losses below 0.05% per day, over months, that adds up. You'd need refrigeration systems or constant resupply. Then there's the biggest obstacle of all. Nobody's paying for it. SpaceX is a launch provider. They build what customers need. NASA wants lunar landers and refueling demos. Commercial clients want satellite deployments. There's no contract for a Starship space station, no funding or timeline. And even Musk himself isn't sold on orbital megastructures. Now, when Jeff Bezos talks about floating cities for 1 trillion people, Musk calls it nonsense. He's not shy about it either. When asked about massive O'Neill cylinder colonies in orbit, Musk said it makes no sense because you'd have to transport vast amounts of mass from planets, moons, and asteroids. It would be like trying to build the USA in the middle of the Atlantic Ocean. His words, not mine. Musk's vision points elsewhere. He's focused on Mars colonization and lunar bases, not pure orbital construction. He said they'll probably have a base on the Moon before going to Mars. For SpaceX, Starship is fundamentally a transportation system. Get to space, get to Mars, build settlements where you have resources and gravity. The challenge with one-way orbital stations is sustainability. Mars pioneer Robert Zubrin put it bluntly, you don't send people on a one-way trip until there are greenhouses and settlements, place to live. An orbiting Starship station without robust infrastructure would quickly become indefensible as a long-term habitat. You'd need supply lines, repair capabilities, and escape options. So what's actually going to happen? In the near term, we'll see Starships left in orbit as fuel depots for lunar missions. We might see them serve as temporary staging posts around the Moon. NASA's already testing docking systems to connect Starship with Orion capsules and the Lunar Gateway. These aren't permanent structures, they're operational tools. But the groundwork matters. Every test flight, every fueling demo, every successful docking brings the technology closer to maturity. SpaceX is driving launch costs down through reusability. They're proving orbital refueling works. They're flying Starships repeatedly. And that's what opens the door to everything else. Maybe not today, maybe not next year, but the foundation is being laid. As Musk said, full reusability is possible, and with it, our notions of what can be built in space are changing. Whether Starships themselves become the building blocks of megastructures or simply ferry components to the Moon and beyond, one thing's certain, the biggest mistake would be assuming we've seen the limit of what's possible. So ask yourself, is the future of space about returning or about never coming back? If Starship is more powerful when it stays in orbit, are we limiting it by forcing reusability everywhere? And if one-way systems unlock stations, fuel depots, and deep space habitats, who decides when that leap is worth taking? If this changed how you see Starship, like the video. Subscribe for grounded, no-hype space analysis.